Today our goal is to be able to take the derivative of products and quotients. We're going to start with products, and this part isn't in your notes. I'd like you to just sit back and listen and really think about what I'm saying and showing you. First of all, let's think about the graphs of f of x equals 2x minus 1 and g of x equals 3x plus 7. If I asked you to graph it, what would it look like? Hopefully you said it's linear. It would look like a line. What does that mean when a graph looks like a line? It means that their slopes are always constant. Constant slopes. Well, what are the slopes specifically of these graphs? Now, if we think of them as y equals mx plus b, we know where to look for the slopes. We just look at the coefficient of the x. So the first one has a slope of 2 and the second one has a slope of 3. Now, as we talked about recently, slope is also derivative. So if I say the slope, what's the slope? Then I'm really asking also what's f prime of x? And f prime of x is 2. Also, the slope of the g graph, g prime of x, that's 3. Okay, so we know the slope of f is 2 and the slope of, I should write that, the slope of f and the slope of g, those two different slopes, 2 and 3, constant slopes, never changing, no matter what x is. Well, what is the slope of the graph of their sum? Well, what does that mean? Let's make a new function, h of x, and let's add them together. So I'm going to say h of x equals, and I'm going to find f of x and g of x and add those, 2x minus 1 plus 3x plus 7, and h of x is 5x plus 6. So the slope of their sum, the slope of h, is h prime of x, which is that coefficient right there, 5. So we added f plus g, and the result took its slope, its derivative, and got 5. If I were to start with the derivatives and say f prime plus g prime, I still get 5. Well, that makes sense because when we take the derivative of a function that is a sum, we can just take the derivative of term by term and then add our result. How about a product? So my next question to you is, what is the slope of the product? Call it k of x, f of x times g of x. Well, if I start by creating k of x out of those two functions, f of x is 2x minus 1, and g of x is 3x plus 7. And I'm going to multiply that out so we can get a better idea of what the graph looks like. So this product results in a parabola. What's the slope of a parabola? Well, where are you asking me to find it? First, the slope is negative, then the slope is 0, then the slope is positive. The slope is always changing. If I ask, like I did before, the slope of k, and we think about it as a derivative, k prime is 12x plus 11. It changes depending on the x value where we're looking. Well, what if I say, what's f prime times g prime, the values that I got up here? The slope of f prime was 2. The slope of g prime was 3. What is 2 times 3? 6. Is that the same as 12x plus 11? Finding the product and then taking the derivative, is it the same as taking the product of the derivatives? No, these are not the same. The point being, if we have a product, it requires use of the product rule. So let's look at what the product rule is. In the product rule, we're saying I'm taking the derivative. Here I'm going to write the derivative with respect to x of the product of two functions. Call it f of x times g of x. We take one function, we multiply it to the derivative of the other function, f of x times g prime of x, plus g of x times f prime of x. the second function times the derivative of the first. Basically, it's one non-derivative with one derivative, and then switch it up, and then add them together. A really important part to think of before you just jump into product rule is to first ask yourself, do I really need product rule? Or can I simplify first such that it's not a product? Ask yourself that question. What do I mean by can I simplify first? Well, number one, I'm supposed to differentiate the following with respect to x. Basically mean find dy dx if the function's called y and it's with respect to x. Now, this is a product. I have x minus 2 times 5x squared plus x cubed. This is a product, but it doesn't have to be. In this one, I can simplify first, so I don't need the product rule. What does it look like when we simplify? Well, we have to FOIL. So that's going to make y 5x cubed plus x to the fourth minus 10x squared minus 2x cubed. Combine like terms, and y still equals x to the fourth plus 3x cubed. Right, subtract those, minus 10x squared. Notice this is still y. Now I have no product. Separate term, 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 things I'm adding and subtracting. So now I can write dy dx and just do each separate derivative. X to the fourth, product rule makes, or sorry, power rule, 4 comes out in front, subtract 1 from the exponent. 3 comes out in front, multiplies, subtract 1 from the exponent. 2 multiplies to the front, subtract 1 from the exponent, and that's it. Product rule not needed. Now that doesn't mean I can't use the product rule. If I prefer product rule at this point, that's fine. But I can simplify first, and now it's not a product. I always like to think of that because sometimes it just is too much work to do the product rule, and I need to save time. Now, how about number 2? Is there any way to make this not a product? What do I have? 5x squared, there's something with x in it, times sine of x, something else with x in it. Now, those parentheses weren't there, but those help me distinguish between the factors of x. Something with x times something else with x. I can't make this not a product, so I'm going to have to use the product rule. I must use the product rule here because I can't make it not a product. So let's start. Sometimes it's helpful to identify the f and the g and then write down the product rule. So I'll say dy dx equals f times g prime plus g times f prime. However, sometimes it's just as easy to talk yourself through one function and the other one's derivative. So one function is 5x squared. The derivative of the other one is cosine of x. Plus g is sine of x. F's derivative is 10x. Now this is a derivative, but we can do a little bit better. We don't need the parentheses all over the place. So let's write dy dx equals 5x squared cosine of x plus, now usually we move the 10x into the front, otherwise it looks like we're multiplying 10x to x. So 10x sine x. And now we have our prettier derivative. Number 3. This is a product. I have something with x in it times something else with x in it. How about you pause the video, try the product rule, come back and check your work. So let's see how you did. Dy dx equals, the first function is 2x minus 3. The second function, its derivative is what I want next. Now remember, if it's helpful, call these f and g and write that your derivative will be fg prime plus gf prime. So g prime is negative sine of x plus g, the second function, as it is, f prime, the derivative of the first function, 2. Again, I have a derivative, so I can leave it like that, but of course we can do a better job of making it look nicer. So what does that look like? Negative, maybe I pull that out in front, and then I don't need parentheses around the sine function. Stick the coefficient 2 in front of the cosine of x. Much better. Next one, we have x squared times sine x times cosine x. So I could think of this as if it's y equals x squared sine of x times cosine of x. Call this function the f and this function the g. And then when I need to get into the derivative of f, so when I need f prime, I'm going to then split it up into two other separate functions. Maybe call this u and call this v, and f prime will be uv prime plus v u prime. That could be tricky. So maybe we think of instead an extension of the product rule, which just looks like this. If y is a function that's a product of three functions, call it f, g, h, f times g times h, then y prime is f prime times the other two plus g prime times the other two plus h prime times the other two. So notice we're just including the derivative of each one in each part. So how does that look for our function, dy dx? Call it f, g, and h like that. F prime is 2x, and then I write the other two functions plus g prime, the derivative of sine of x, is cosine of x. And then I just write the other two functions, x squared and cosine x. And then h prime, the derivative of cosine x, is negative sine of x. And then I write the other two functions. And then simplify as needed. Pretty cool.